On this video, we're going to look at some more calculus exam questions. Sarah threw the ball at a basket, so basketball question, leaving at A here and coming in and landing at B in the net. Using coordinate plane, A is minus 0.5, 2.565, and B is 4.5, 3.05. Just put that beside B. And A minus 0.5, 2.565. F of x is equal to this. Find the max height. Okay, so we know max height is dy dx. So solve this. For it equal to 0, that will give us our x value, and we put our y value back into f of x because f of x gives us our y value at any point. Okay, dy dx twice by minus 0.274. It's going to be minus 0.548 is two of them, and that will be x. And then it's just plus 1.193. If we let this equal 0, x is going to be, but it'll be positive. Obviously, we can see that here, the max height somewhere up here. So x is going to be 1.193 divided by 0.548. And if you type that into a calculator, you're going to get 2.177. So this is my x coordinate. So we're looking to find our y coordinate. So f of 2.177, so when we calculator use here, is equal to minus 0.274 by x squared, 2.177 to be squared, plus 1.193 times 2.177. And then we're going to have to add on 3.23. Just type this into your calculator and you're going to get a y value of 4.529. So my max height is 2.177 and 4.529. And actually, you can see here in the diagram, it does match up with what we have. Okay, let's look at the next part. Find the acute angle to the horizontal. Okay, so acute angle. So what do we know here? We know that dy dx is equal to the tan of the angle, or that's what we should know, or you should know at this point. So at the point, well, x is going to be, let's go back up, x is going to be at the point of entry here at B, x is 4.5. So we need the tan of theta when x is equal to 4.5, or dy dx when x is equal to 4.5. So we have minus 0.548 times 4.5 plus 1.193. So that's going to give me minus 1.27. And if we get the inverse tan of minus 1.27, this will give me the angle of entry. So it's giving me 51.78 degrees to the nearest degree we're asked for here, 52 degrees. Okay, she's taking a second throw on the next part. She took a second throw which followed this green parabola g of x. The ball left her hand at the point C, 0, 2. The graph y is equal to g of x is the image of y is equal to f of x under the translation, which maps A onto C. Okay, well, let's just jot that down real quick. A onto C. So A is the point minus 0.5. What was the y value of A? 2.565. And if that maps to C, if that maps to my C value, which is 0, 2, we're told, what is happening in this translation? Well, my x is going up by 0.5 and my y is going down 0.565. So it looks like use your result from A part 1 to show that the center of the ball reaches max height at this point. Well, we have the other max height point. What was the other max height point? Let's just double check it. 2.177, 4.529. 2.177, 4.529. You nearly should see the answer at this point. What's happening here? X is going down 0.5. So we have to add 0.5 to my X to get 2.677. And my Y, I have to take away 0.565. And that's going to give me 3.964, which are the values up above. So you can see here the translation maps it to this max height that they gave us in the question. And then hence or otherwise find the equation of the parabola. Okay, let's see what way we're going to approach this. The equation of the parabola. Well, we have max height. So when we have the max height, we can use this equation for the equation. It's A by x minus h to be squared, like you're completing the square question, plus k, where hk is the max point. And our max point is 2.677, 3.964. And the hence here gives you a clue that you could use this answer here. So that just leaves us calculating A. So let's see, well, let's put this in. A times x minus 2.677 to be squared plus 3.964. So that's g of x. So we just need to calculate A. So if we have a value for x, any other point on the curve, which we do actually here, we have the point 0, 2, we can say g of 0 is equal to 2. G of 0 equals 2. Therefore, if we put 0 in for x, we're going to get A by just minus 2.677 to be squared plus 3.964. So that's going to give me, 7.166A. This is going to be equal to 2. So that's plus 3.964 equals 2. So that equals 2 minus 3.964. So A is equal to 2 minus 3.964 divided by 7.166. And to avoid calculator use throughout the question, we're going to get minus 0.274. So the equation of the parabola becomes, I'll just call it EOP. The equation of the parabola is minus 0.274 times x minus 2.677 to be squared plus 3.964. The equation of this parabola. In this question you were asked to differentiate x minus the square root of x plus 6 with respect to x. So we write that out. Y is equal to x minus, well, we'll put this to the power of a half, it'll be easier to differentiate. So we're going to have dy dx is equal to 1 minus a half times x plus 6 to the power of minus a half, which is 1 minus, well, the only thing left on top here is a 1 over twice the square root of x plus 6. And we're asked to find the turning point of this function as well. This is a 25 mark question, as you can see here. Really straightforward. Turning point, dy dx is equal to 0. That will give me my x value. We plug our x value back into here to get our y value. So what do we got here? We got 1 equals 1 over twice the square root of x plus 6. That means that the denominator here has to be equal to 1, 1 divided by 1. So 2 by the square root of x plus 6 has to be equal to 1. If we square both sides, they're surd equations. 4 by x plus 6 is equal to 1 squared. 4x plus 24 is equal to 1. Is that going to give me 4x equals minus 23? X is equal to minus 23 over 4. So that means that y is equal to minus 23 over 4 minus the square root of minus 23 over 4 plus 6. Now 6 is equal to 24 over 4. So we're going to get just 1 over 4. So y is equal to minus 23 over 4 minus the square root of 1 over 4. And a half square gives 1 over 4. So that's minus 23 over 4 minus 1 over 2, which is the same as 2 over 4, which is minus 25 over 4. So the max point is minus 23 over 4 and minus 25 over 4. In this question we were given a diagram of a plane coming into land, and it's 150 meters above the ground before it begins its descent at this point here. Taking O as the origin, so here's my origin, and the plane lands horizontally, so it's coming in, of course, when the plane lands, its wheels hit the ground, so it's going to be horizontal. Describe the path of the plane. Well, the back of the plane will land first, but in this question, obviously for mathematical reasons, the whole plane lands at the same time. The origin is O, x f of x approximately describes the path of the plane's descent, where f of x is equal to this function. Show d is equal to 0. Well, the information we have is that 0, 0 is on this function. So f of 0 is equal to 0. Therefore, what do we have here? We're just going to have, well, they're all zeros. We're going to have 0 plus 0 plus 0 plus d is equal to 0. So d obviously has to be equal to 0. Nice easy starting point for this one. Using the fact that p is the point minus 5, 0.15, or otherwise, show c is equal to 0 also. So f of minus 5 is equal to 0.15. So if we put that in, therefore we got 0.0024 x cubed. So I'll put my minus 5 in, by minus 5 to be cubed, plus 0.018 by minus 5 to be squared equals 0.15. Sorry, we've got to put our c in. Just assuming it was 0, so plus c times minus 5, and that's going to be equal to 0.15. So if we multiply this out, just calculator use here, actually going to work out easily. We're going to get, calculators give me a fraction for this one, minus 3 over 10 plus 9 over 20 minus 5c equals 0.15. So fractions and decimals in the same question here. So we're going to get 0.3, 0.45, so that's actually 0.15 on the left, minus 5c equals 0.15. So 5c is equal to 0, so c is equal to 0. So that's part 2 done. Part 3, of course, we're going to be asked for the derivative at some point in these questions when x is equal to minus 4. So let's have a look at the derivative. I'll just write out the function again. F of x is equal to 0.0024 x cubed plus 0.018 x squared. C and d were 0. So f prime x, 3 of them, 3 0.024s, is going to be 72, 72 x squared, and 2 18s is 36, so plus 0.036 x. And we're asked when x is minus 4, so f prime minus 4, again calculator use when you've got decimals like this, by minus 4 to be squared, or just put 4 squared in if you're happy to do that. 0.036 by minus 4, and that's going to give 0.1152 minus 0.436 is 144, and that's going to give me minus 0.0288. Next part, use your answer to part 3 to find the angle. We've seen this question already. They find the angle at which the plane is descending when it's equal to 4 kilometers. So x equals 4. So find your derivative, put 4 in. If we look at our diagram, x is actually minus 4, isn't it, from the previous part? Minus 4, because here's minus 1, minus 2, minus 3, minus 4. So x is minus 4 at this point, 4k away. Just make it a bit clearer. So we have a derivative. So we're looking, well, we have f prime minus 4 already. It's equal to minus 0.0288. So the inverse tan of this number is going to give me, I've got tiny nearest degree here, it's a tiny number, 1.649 degrees, and to the nearest degrees, 2 degrees. So it's not coming down very steeply. Next part. Show minus 2.5, 0.0075 is the point of inflection. So the point of inflection is f prime prime x. If we solve that, we'll get our x value for the point of inflection. We let it equal 0 to solve it. So what have we got? We have f prime x 0.0072. So is equal to, I'll do f of x first. F of x is equal to 0.0072 x squared plus 0.036x. So f double prime x is 144, 0.0 and then 144 x plus 0.036. If that's equal to 0, we get x to be 0.0144x equals minus 0.036. You can obviously do this in one step. X is minus 0.036 divided by 0.0144. That in fact gives me x to be minus 2.5. Okay, we're on track here. That's what they were looking for. And to get our y value, we always use the original function. So y is equal to the original function 0.024 x cubed, so minus 2.5 to be cubed, and we also had 0.018 x squared plus 0.018 by minus 2.5 to be squared, and if we do that sum, we're going to get 0.075. So therefore, point of inflection is equal to minus 2.5, 0.075, and that's quadrat demonstrandum. Okay, next point. If xy is a point on the curve, y is equal to f of x, verify that minus x minus 5 and minus y plus 0.15 is also a point on the curve. So we can put this value in for x, and it will be equal to minus y plus 0.15. So let's do that. Okay, so f of x is equal to 0.0024 x cubed. So there's a bit of work actually involved in this, unless you can come up with a better way to do it. And plus 0.018 x squared. So I have my x value, minus x minus 5 to be cubed, plus 0.018 by minus x minus 5 to be squared. So this is going to work out to be, so I'd square these off to the side. You could probably square this out now, 0.024, do it on a bit of rough work off to the side. Minus x minus 5 to be squared is x squared plus 10x plus 25. And if we multiply that by minus x minus 5, we're going to get minus x cubed. We're going to get minus 5x squared minus 10x squared minus 15x squared. We're going to get minus 50x minus 25x is minus 75x. We're going to get minus 125. So I can put that guy in here, minus x cubed minus 15x squared minus 75x minus 125, and the 0.018 gets multiplied by the x squared plus 10x plus 25. So multiplying these out, we're going to get minus 0.0024 x cubed. 0.024 by 15, we're going to get minus 0.036 x squared. We're going to get minus 0.18x, and we're going to get minus 0.3. So that's this guy multiplied out. then actually, what are we going to get? We're going to get plus. I'm going to line them up here. This one by this one, this one by this one, and this one by this one. We're going to get plus 0.018 x squared. We're going to get plus 0.18x. They're going to cancel. 10 of them. So plus 0.18x. And 0.018 by 25 is plus 0.45. So what's that going to leave us with? This is a crazy function. So we're going to get f of minus x minus 5 2b minus 0.0024x cubed. These cancel. We're going to get minus 0.018 x squared, and we're going to get plus 0.15. And we're asked to show that that would give you minus y plus 0.15. Well, okay, f of x is equal to y, so minus y is equal to, here's my f of x, minus y is 0.0024 x cubed plus, no, it's gonna, I'll just change, I'll put the minuses now, minus, both of them become minus 0.018 x squared, and if I add plus 0.15, that second part, you can see here that these two things are in fact equal. Therefore, that point minus x minus 5, just get rid of the bracket, comma, minus x minus 5, and minus y plus 0.15 is on the curve. So whoever came up with that question in the State Examinations Commission needs their head examined. Too much algebra involved. Just a frustrating question to get in the middle of a Leaving Cert exam, just multiplying out all these things. So whoever it was, please make yourself known. Now we're asked to find the image of this under symmetry in the point of inflection. So let's write this down. Symmetry on the point of inflection at this point here. Okay, the point of inflection we got up above, what was it? Minus 2.5, 0.075. So what's happening here? To go from here to here, bring it off to the left here, we have to add x to get rid of the x, and we have to add 2.5 as well to go from minus 5 to 2.5. So if I do the same, I'm adding x plus 2.5 to that value. Actually, you can see here we're going to get to 0. What happens on the other side? We don't get to 0. We get to x. The 0 is the number. We get to x. So what happens on the other side here? So on this case, going down this way, we are having to add y and take away. Well, that's 75 and 150. We have to take away 0.075. So if we add y and take away 0.075, we do in fact get the y and find the image. So xy is the image. This is our answer of that point. So quite a long question here, 7 parts. In practice them, a lot of the calculus functions material that gets crossed over comes into this question. In this question, there's an oil spill offshore in an area of calm water with no currents. The oil is spilling at a rate of 4 by 10 to the power 6 centimeters cubed per minute, and the oil floats on top of the water. Complete the table below to show the total volume of oil on the water after each of the first 6 minutes, and we were given this 8 after 2 minutes. And you can see here that it's by 10 to the power 6, so it has to be 4 in here, 12, 16, 20 and 24. A nice easy intro into a question that has a few difficult parts. So draw a graph to show the volume of oil, a linear graph at Leaving Cert higher level. So after 0, before the spill, 0, 0, so the points on this graph, and you were given this scale along the left hand side here of, well, it was going up in 4s, so I'll just put that on 4, 8, 12, 16, 20, 24. So I'm just going to put the first point and last point, 1, 4, And if I put 624 on and connect those 2 points as best I can, you will have your linear graph. Now you'll be putting, because you're given the graph in the exam and it's drawn to scale, it's easy enough to just complete this graph. So a nice easy second part. And then in part 3, you're asked to write an equation for the volume of the oil in the water after t minutes. Well, the volume of oil in the water after 1 minute is 4 by 10 to the power 6. After 2 minutes, it's 8 by 10 to the power 6. After t minutes, it's 4 by 10 to the power 6 times t, instead of having times 1, 2, 3, 4, 5, 6. So the spilled oil forms a circular oil slick. So if I just do a little sketch, here's my circular oil slick. So the mistake a lot of people would make in this question, you're thinking circle, but it's 1 millimeter thick. So if it's 1 meter thick, 1 millimeter thick, what does it actually form? It forms a cylinder. So it's not just a 2D circle. And the volume of a cylinder is pi r squared h. So that's the equation we're going to need in this part. So write an equation for the volume when its radius is r. And we know here we have the height 0.1. So we have pi by r squared by 0.1, or 0.1 pi r squared. And that's centimeters cubed. Now you can type this into a calculator and get your decimalized version. And that will give you 0.3142. That's my 0.1 by pi r squared. That's in centimeters cubed. So either one of these answers in terms of pi is probably a nicer way to look at it. Find the rate. Okay, once we're thinking rate of change, dy dx, or what have we got here? Well, always I say when we get these questions, radius, we're looking for the rate in centimeters cubed per minute at which the radius is increasing. The radius increases over time. We have volume is pi r squared h. dv dh is going to be, dv dr, and we have up here h is 0.1. That's not going to change. So we have 0.1 pi r squared. So that's volume. So dv dr, we differentiate this with respect to r. 2 by 0.1, 0.2 pi r. So dv dr is 0.2 pi r at any point. We're looking for the r dt. So if we write out the r dt, what do we have to get the r dt? Well, we can see here we have dv dr. So we need dr dv. So I can invert this, and I'd have to multiply that. I need a t on the bottom. So I have a v on top. So I need to get dv dt. And that will bring me back to, I have volume in terms of t up here. That's why they've asked us this question. So 4 by 10 to the power of 6 t. V is equal to 4 by 10 to the power of 6 times t. So if I differentiate 5t, I get 5. So it's just the constant in front of it. dv dt is 4 by 10 to the power of 6. So if I fill that information in here, that's over 1. So dr dv, dr dt is equal to dr dv, which is 1 over 0.2 pi r. And then on top we have dv dt, which is 4 by 10 to the power of 6. And we're asked for when the radius is 50 meters. Now be careful here, 50 meters is equal to, we have to multiply by 100, it's 5,000 centimeters. So the r dt when the radius is 5,000 centimeters is going to be 4 by 10 to the power of 6 divided by 0.2, not 0.5, 0.2 by 5,000 by pi. So what can I do here? By 4 by 10 to the power of 6 on top, I can cancel 3 of those. That's going to give me 4 by 10 to the power of 3. And that's going to be over 5. 0.2 is 1, so that's just over pi. So actually that tidies up nice and quickly. dr dt, 4,000 over pi, and if we do that as a number, dr dt is going to give me 1273 rounded off. and that is in centimeters per minute. In part 6, we're asked to show that the area of the water covered by the oil slick is increasing at a constant rate, and it gives you the rate 4 by 10 to the power 7. So the area is the circle part, which is pi r squared. So we can get the ADR, which will help us see what we need. The ADR is equal to 2 pi r. Now the area increasing at a constant rate. So mute your phone when you're studying. The ADR is 2 pi r, and area over time we're looking for here, area at a constant rate. So we're looking for the area increasing over time, and we have the ADR, so we can put that in straight away. And then we'll see the third part of this chain rule. We need dt on the bottom, and we would have to get rid of our dr. Now, is dr dt what we had the last time? It is. I might take this version of it and see, does it simplify down? So that's going to give me 2 pi r times 4 by 10 to the power of 3, I'll leave it as, over pi. So see here, my pi's cancel. And actually I've left my r out here. It's actually 4 by 10 to the power of, I need to get my r back out at 50 meters. So it's 4 by 10 to the power of 6 over 0.2 pi r. So my r's will cancel. 2 divided by 0.2 is 10. So I have 10 by 4 by 10 to the power of 6, which is equal to 4 by 10 to the power of 7, which thankfully is what they were asking for here. In the last part of this question, the area, or the land, nearest land is 1 kilometer away. Okay, 1,000 meters. We're dealing in centimeters here. So 1, 2, 3, 4, 5, 10 to the power of 5 centimeters. It's away from the point at which the oil slick be land. So here's our oil slick, here's our land. So how long is it going to take to get to here? So we're going to have to get it. We have the area here. The area of this circle is pi r squared. So it's going in both directions. So the radius is just going to be the distance to here. So that's going to be pi by 10 to the power of 5 to be squared. So the area of this circle will need to be pi by 10 to the power of 10 before it reaches land. And if we have the speed, or the rate, which was the last question, wasn't it? The rate at which it's getting there is 4 by 10 to the power of 7. So the distance it has to travel is pi by 10 to the power of 10. And the rate at which it's traveling at is 4 by 10 to the power of 7. So that's going to give me pi by 10 to the power of 3 over 4. And that's going to be 1,000 pi, 1,000 by 3.142, 3.142 divided by 4. And if I divide that in, I'm going to get 7 minus 3, 8, 5.4. That will be in minutes. And if I convert this to hours, to the nearest hour, so I need to divide by 60, I'm going to get 13 hours. Well, actually, I don't need the minute part. I won't need bother to work that out. 13.09, which is 13 hours. So really good question, the oil slick question. Practice these and move on to the third video of calculus exam questions.